So this question is reminiscent of the problem we had in the homework about the women's softball diamond. Okay, and I thought, oh, there's another diamond that's right in our own city, and here it is. It is our own city. It's right here, this diamond. Well, except that the computer thought that it was a circle, but whatever. Okay, so question reads, the Washington, D.C. was originally intended to be a perfect square, 10 miles per side. At the north side now lies Silver Spring. At the south, Alexandria. And at the west, Falls Church, and the east, Capitol Heights. The White House is just 7 miles due south of the top corner of this square. So if I just draw a line like this, and so right here would be, oh, who knows what, but actually it's going to be somewhere around here is the White House. Okay. Well, here, let me just, off to the side, let me explain something here. We have 10, 10, and it's a 45, 45, 90 right triangle. So this whole thing from top to bottom is like 10 times root 2. So it's like 1.41 times 10. So that whole thing is 14.1 miles. So if we're going to be 7 miles due south, we're going to be just slightly above, right? Just slightly above the middle. So maybe like that. All right? Just slightly above the middle. So that's how you know you're just slightly above the middle. Okay. So it's 7 miles due south of the top corner of this square. Find the distance from the White House to the corner of the city at Capitol Heights. So we're trying to find this distance, which is going to be pretty close to 7 because, I mean, we're very close to being in the middle. But what I want you to notice here is you have 10 miles right there, 7 miles right here, and 45 degrees. So I'm going to write this off to the side. I have 10 and right here we have 7, 10. It is not a 45, 45, 90, but it's close to it. But this guy is 45 degrees. Okay? And what we want to know is this side of the triangle. So let's label it. First of all, is this a law of sines or a law of cosines? Well, if it were a law of sines, we'd have to have a side and an opposite angle, both with information. But here, every side, like the 7, is across from an angle we don't know. This 10 is across from an angle we don't know. And the side we don't know is across from the 45. So there's no match. So we cannot use the law of sines. So therefore, we must use the law of cosines. And so, and when we use the law of cosines for side, 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 it doesn't matter what we label anything, but for this case it does. We need to say C is 45 degrees. And then capital C is the opposite side. So we have A squared plus B squared is equal to C squared plus 2AB cosine little c. There we go. So A is squared makes 49. B squared is 100. C squared is, I don't know. That's the whole point. We don't know what it is. Plus 2AB, so that's 140, right? Because 70 times 2 is 140. Cosine of 45 degrees. This particular one we know. Cosine of 45 degrees is 1 over root 2. Okay? So let's take this a little further. 149 equals C squared plus 140 times 1 over root 2. Right? 149 minus 140 over root 2 is equal to C squared. It looks like it's about time to pull out the calculator here. 149 minus 140 divided by 2 to the power of 0.5 equals, aha, pretty close to 50. I would say really, really, really close to 50. And I have to raise that to the 0.5 equals 7.07142. And this is in miles. Okay? So, yeah, that's it. That's all you need to know for solving any side angle side problem. And hopefully you enjoyed that.